All right, hello everyone. Should be a pretty quick video on lesson 5 here, expected value. Expected value is kind of what it sounds like. So I'm going to start off with this question that sounds familiar to you. Carly's a good student. On her first 4 tests, she got a 92, an 88, an 86, and a 91. About what grade would you expect her to get on her 5th quiz? So if somebody asks you that question, another way to say that is what grade would you expect from her because of her performance so far? And I'm thinking that a lot of you would probably say, well, let's find out what she does on average. Let's take her average for her tests and see what that is. And you all know how to find averages, I know this. If you add up these 4 numbers and divide by 4, you would get about an 89.25. And I think that's a good place to start. On average, that's about what Carly's doing so far, so you would expect her to get something around there, 89 perhaps, maybe a 90 on her next quiz if she's consistent. So we move into this idea of expected value. And there's a definition here for sure that we're going to use, kind of like a formula. But it's a little simpler than even that is leading you to believe right now. So an expected value means that you are going to, and you hopefully have seen this sigma before. This is a way that we say to sum up things. So we're going to sum up some things, and those things that we're going to sum up are simply each value that we could potentially have times the probability corresponding to that value. So if we have lots of various things that could happen, and we have probabilities of each of those things happening, if we multiply that probability to the value and add them all up, we would get what we call an expected value. So another way to think about expected value is to think of it as the mean or the average of the distribution of a random variable. It is as if we are calculating a long run average. And that's why we can get away with it for some things that we don't actually have to perform forever. But we could say, if I did this a large number of times, what would I expect to happen? And I think that's going to become a little clearer with some examples. So let's do some of those. This first example, you have a table here that provides the probability distribution for the number of heads occurring when 2 coins are flipped. So obviously, if you are flipping 2 coins, you have the potential things that could happen. You get 0 heads, you get 1 head, or you get 2. Those are the things that could happen when you flip 2 coins. These are the probabilities associated with each of those scenarios happening. And I don't think it would take too much to think about why that would be the case. If you're wondering where these numbers come from, think about the possibilities of things happening if you toss 2 coins. You can get head, head, tail, tail, head, tail, tail, head. You've got 4 things that could happen, and these probabilities are associated with those things that could happen. So if 2 coins were flipped many, many times, how many heads would you expect to occur on average? So if I'm using my formal definition or formula up there, all I need to do is say, to get 0, that has a probability of 0.25. So I'm going to multiply those. I'm going to add to that the possibility of getting 1, which has the probability of 0.5, and then the possibility of getting 2, which has a probability of 0.25. And all I have to do is multiply these and add them together, and I'd actually get a 1, which is kind of not very exciting. But what that means is that if I flip 2 coins many, many times, I would expect on average, I would get, or I would toss 1 head. That's what that means. All right, let's think about it in a slightly different scenario. So look at example 2. It says the following chart shows the probability of making certain amounts of money in 2 projects. Using expected value, which project should your company choose? So take a look at these 2 projects here. It's kind of interesting to consider. You've got the potential to make a lot of money and then less than that, a lot of money and then less than that. These numbers are the probability of your company actually doing that from these projects. So you've got a 40% chance of making $2 million. You got a 60% chance of making $500,000. If you're trying to compare these 2 projects, though, this one has a higher high, but it has a lower low. and they have different probabilities. There's a greater probability that it's going to go low than it is going to go high here. But if it went high, that'd be higher than this high. So you've got a bunch of variables here, a bunch of things going on that could potentially give you a hard time deciding which project to do. So what we would do in this scenario is find the expected value from each project and see which one is giving us the better shot. So for project A, I'd say, okay, I've got the value of $2 million that is potentially going to happen. The probability of that happening is 0.4, or I have 500,000 happening. Probability of that is 0.6. I would add that together, and this is what I get if I do that. So this is my expected value, and I'll put that as money. That is expected money from project A, just kind of weighing the different things that could happen. So let's do the same thing for project B. Project B, you could get $3 million. That's a 30% chance, or $200,000, and that is a 70% chance. If I add that up together, here is what I get for that. So now I can compare these two and say, looks like project A is actually going to have the expectation of higher amounts of money. So I'm going to go with project A. So it can help you make decisions. Another example, example 3 here, we don't have any context for example 3, but we do have it here as a bar chart here. So we still have 0, 1, 2, 3. These are the X values. These are the things that could happen. And we have the associated probabilities for each of them. So if I wanted to find the expected value for X here, once again, I'm just going to take the value and multiply by its correlated probability. I'm going to do that across the board. And I'm going to simply add all that up, and I'm going to get about a 1.1. So my expected value for X in this problem is about a 1.1. And you can see 1.1, that would make sense, that it would be between 1 and 2, but leaning more towards the 1 because you've got greater probabilities here in that front end. All right, last example. The number of defects observed in the paint of a newly manufactured car is a discrete random variable. The probability distribution of this random variable is shown in the table. So you've got the number of defects and you've got the probability over time that they've noticed. The probability the car brought in would have that number of defects. If large numbers of cars were inspected, what would you expect to see for the average number of defects per car? Okay, so if I did this over a large time, or if I'm thinking, over a year or 2 years, what's the average number of defects that I would expect to see? So again, there's lots of numbers here, but it's the same thing. It's not a hard process. It just can be a little annoying if you have a lot of numbers. But again, I'm just multiplying the number of defects by the probability associated with them. And I will add all of this up. And when I do that, I get 2.35 defects. So on average, I would expect a car that came in to have between 2 and 3, we could say. Interpret the expected value calculated in, it's really problem 4, so we'll just say interpret the expected value calculated here. In context, so again, in context, I'm saying that I would expect if a large number of cars were brought in that I would have a 2.35 defects. Explain why it is not reasonable to say that every car will have the expected number of defects. Well, first of all, I can't have 0.35 defects. So again, this is an average. So it's just kind of giving us an idea. And secondly, averages, you know how they work. Just because this is the number I get doesn't mean that every single car has that many defects. There's going to be some that are greater and there's going to be some that are lower. That's how averages work. So I would not expect every car to have this many, but again, on average, that's what I would expect to see. All right, so that is expected value. We will be practicing this and doing more with it in class. See you then.